Hello and welcome to this presentation on psychophysical parameters of sound. We'll begin with looking at the concept of psychophysical parameters to then determine what the actual difference between sound and hearing is. We'll continue on to the variations of sound and finishing off with a look at binaural sound localization. So let's look into what psychophysics actually is. Well, psychophysics is the quantitative study of the correlations between physical and psychological occurrences. So the search of omega, which is the measure of behavior, as a function of the physical property of sound, or S. So basically what we're talking about is the relationship between external physical stimulus and the behavioral and sensational perception that we acquire from it. Now, seeing as we only have 6 minutes together, we'll focus on the psychoacoustic branch of psychophysics. So, what's the difference between sound and hearing? You see, hearing is quite simply the perception of external sounds. Your psyche responds to a physical stimuli. Now, sound, on the other hand, is made up of vibrations causing the molecules in the medium through which it travels to be pressed together and pulled apart, resulting in a series of compressions and rarefactions. It is this oscillating sequence of pressure waves that we refer to as sound waves. Now, there are 3 primary dimensions of auditory perception: loudness, pitch, and timbre. Loudness relates to the intensity of sound, or the energy per time per area at the point of reception, whereas pitch allows us to perceive the intonation in a language and notes in a melody. It's mainly determined by the fundamental frequency of a note. In contrast, timbre allows for the distinction between vowels and consonants, or the distinguishable characteristics of a tone. It describes the complexity of a sound. Now, the illustration to the right demonstrates both the direct effects of determination of each dimension as well as its other influencing connections. Most sounds that we perceive, however, are a mixture between various frequencies, intensities, and waveforms. And as you can see, we are in general able to perceive sounds within the frequency range of 20 to 20,000 Hz. It's the combination of pitch and timbre that allows for us to recognize people by the sound of their voices. Now, moving on to tremolo and vibrato, these are variations describing musical effects achieved through the use of an instrument or our own voices, as an example. Tremolo describes the steady increase and decrease in volume or intensity, whereas vibrato describes the same changes in pitch. These fluctuations are measured by either amplitude or frequency over time and all play part in how we actually hear and perceive sounds. Now finally, with a basic grasp of sound, the defining factors and the measurements of it, this brings us to our final segment covering the binaural determination of sound localization. Now, what this entails is the spatial aspects of sound perception. You see, there are 2 main physical cues that determine how we perceive the location of an incoming sound source. Unless the source of a sound is directly positioned in front or behind you, it is more likely that sound waves will reach the ear closer to the source before arriving to the other. For binaural source localization, the information of 2 microphones, or in this case, your 2 ears, are needed in 2 cues. The interaural time difference, or ITD, is the difference in time it takes for the sound waves to travel to both of your ears, and makes up the first physical cue of localization. The second cue to be considered is the interaural intensity difference, or the interaural level difference, ILD or IID, a so-called shadowing effect resulting from the cranial interference in sound wave transmission. Now, why is this relevant to medicine? Well, apart from involving auricular physioanatomy and the nervous as well as cognitive functions attached to hearing, there are still many unclarities regarding the psychophysical responses to sound, including characteristical perceptive delays across species, the neurological mechanisms at play, and otological conditions. And finally, I would like to thank you for your attention. I hope you enjoyed it.